Your sound
Yep.
is okay.
Okay, good.
We also have some people in here already, so we can ask them. Can everybody hear us?
Hello, everybody.
Hello, everybody.
If you can, just let us know in the chat.
I wonder if it's delayed too, maybe on their end.
I
On
think
this,
a little bit, yeah.
it's weird. It's not usually this badly delayed. So, okay, people can hear us. Hello.
Fantastic. Hello, everybody.
Where is everybody from?
Yeah, where are you joining from? Let us know.
So Lou is in London.
Okay.
Hello.
Reshma is in New York.
Yep.
And I am currently in Ohio. Oh, Atlanta. Ireland. Yeah, I think honestly,
Ireland.
like this is part of the coolest thing is that when people come into like webinars and stuff and just start saying where they're from, like Ethiopia, it's like everywhere in the world. It's crazy.
It is
Peru.
so cool.
Peru.
Oh,
Look at that. It's like
wow.
all different, just different countries.
I think that's my first Peruvian. I'm very excited.
Really?
Yeah.
I like Peruvian food.
It is good. Have you been to Peru?
No, I haven't.
I went long time ago. I went to Machu Picchu.
Oh, wow.
London, Georgia, the country.
I wonder if Peruvians go to Machu Picchu or if it's like, maybe Rosa could answer it.
Yeah.
I've got a couple of people from Kenya.
Yeah, it's probably from the AI Kenya group, I think.
Another Londoner.
Or Masters cohorts, or
yeah,
Alfred Ongera's group. Yeah.
Hi, Karen.
Cloud Study Networking.
I'm like waving to people like, hi. I mean, they can see us.
Texas.
We're in Texas. Texas is huge. That doesn't count. Texas is like, it's a big.
Is it bigger than the UK? Must be.
By size, I don't know. Oh, Tina is up early.
San Francisco. Wow. Yes, that's 7 a.m. Brazil. Oh, Brazil.
I'm curious. Has anybody here? Should we do a poll on like if people are if they're familiar with Neo or not? I'm going to record the webinar too. I'm not going to start quite yet. I'll start like when we actually start. So we'll give it like a few minutes to like let people get in and But did you say you guys wanted to do the poly stuff like on if people use Neo or?
Yeah. So maybe have you come across? So I think maybe more of a. Have you heard of Neo4j before? Yes, I have. No, I haven't. Yes, I have. I've had a play. Why not?
Yeah, that's a good idea. I'm curious to see if. Oh my God, there's a lot of Philly people.
Yeah,
I'm from Philly too. I just happen to be in Ohio right now. We're curious to know if anybody here is like used Neo4j or they're familiar with it or like.
Yeah.
I guess like to make it simple, you could be like intro level, or played with it.
We're gonna be doing cool stuff. Yeah. Don't let the title put you off. If you're completely brand new to Neo4j because some random person just grabbed you and said, "Hey, come to this session." Do not worry, we're gonna do some cool stuff.
Yeah, I'm curious on who's heard of Neo4j and who's played with Neo4j, and who's actually tried to use it.
Who's not at all. I did not know the existence of Neo4j up until about when they signed up. I would love to know.
I feel like a lot of people heard about it, but like don't know what it is. That's my assumption. Here, Christina's from New York.
Singapore. That's Singapore. That's what, about 11 o'clock in the evening? 11, 12 o'clock. That's a late night.
I'll tell you what, I think that's better than 7 o'clock in the morning in San Francisco.
Give me 7 o'clock in the morning over 11 o'clock at night any day. Oh, look at this. You got the poll is up, everybody.
Nice.
Christina's there from New York. Oh, Alfred, good to see you.
I don't know what I'm supposed to put here. I'm going to put a Neo4j user. Oh, this is cool. Oh my God, this is so cool. Okay, so we have mostly newbies and heard of it, not used it.
Hey, nice.
A small percentage of people have tried it.
Yeah.
There's 2 Neo4j users, which I'm assuming might be.
I may have put myself down as a Neo4j
Okay,
user,
so it's you and I.
I like John's comment. Didn't know about it. I don't know how I ever managed to live without knowing about it. Exactly. That's how I felt.
Isn't it crazy? You know what's insane? I remember when I first heard about Neo4j and like graph database, and like I looked it up online, I read about it. And in my mind, I thought that a graph database was like kind of like an auto ML tool where you just like dump data in it and just gives you a bunch of charts. That's what I was sure what a graph database was. I didn't think about like anything related to like networks and like whatever. And then I actually found out what it was, and I was like, oh my God, I was blown away because I feel like it's so like intuitive and it makes so much sense for so many things. I was like, how? I felt like I lived under a rock, but it didn't. You know, it's like, but the majority of people didn't know about it. It just so happens that 75% of the Fortune 50 companies are using it for something.
Wow.
It's the fastest growing database category. It grew 1,000% in 10 years, according to DB Engines. That's insane. Like, it's just, graph databases are like,
so much fun.
Yeah.
Yeah. And everybody. So we're going to talk about it a bit more formally. So we haven't officially started. We're probably going to start in a couple of minutes, but we are all going to be coding along. Yeah. So we're going to do a beginning bit where we're going to be. I'm going to tell you about, what is a graph, what's a graph database, how might you spot situations where it'd be a good fit. And then we are going to be rolling up our sleeves and having a go. And we're going to be doing that in the sandbox. So you don't have to download anything. You don't need to install anything. It's all there and ready. So we're going to give you links. So don't panic. We'll give you links. We're going to do it all together. So we're all going to do it. I'm going to be keeping an eye out for your questions. So if you get, stuck, and hopefully we'll be able to pick that up as we go along. For those of you who are super eager and going, show me the sandbox right now, you'll spot there's a sticky at the top of the chat. So you can click on that, and that's going to fast track you to the blank sandbox. So if you need to sort out a login, so you will need to log into the sandbox, and you've got a couple of options with that. You can either use your social media, so you can log in with, for example, your Google account or with Facebook, or what you can do as well is you'll notice there's another button that says create, and then you can just put in your email address and the password. So you've got a couple of options. Yes, no, we haven't started yet. You are right on time. I just thought I would quickly, site cannot be reached. Let me have a quick look at that.
Yeah, we'll work on it. Plus, actually, I don't think we need the sandbox quite yet, right, Lou?
No, but it doesn't hurt. Yeah, so I think, let me update the sticky. So I think like the looks like the link's been
okay, she's gonna, all right, Lou's gonna update it. She's gonna first kind of do a little overview first and then get into the sandbox.
Yeah.
Thank you, David. David put a link in there too for the sandbox, and also did Reshima.
Yeah, I guess it just didn't have the login at the end, but I can see it on my screen, so to log in.
Yeah, so it looks like most of the people that we have here are very, very new. Only about 6% of people have actually tried it. 3% dabble in it. So, which is great. I think that this is honestly, like, I think graphs are game changing. So I get really excited when like people learn like the intro level area to like, understand what it could be used for and how amazing it is. Reshima's hooked.
I love graphs. Oh my God, my blog. Let me find my blog.
Oh yeah, the blog. Hey, should we do a poll on who's coming to Nodes 2020?
Oh, go on then.
Oh, so I'm just going to tell everybody really quick that we're going to do this before we start recording because I don't think it needs to be on the recording because it's going to be like too old by that time. But we are doing a conference. It's going to be a 6-track, 9-hour conference, virtual conference, obviously virtual, called Nodes 2020. It's Neo4j Online Developer Expo and Summit. And the community groups that probably invited you to, or like how you heard about this event, they're the ones, like they're community partners of Nodes 2020, which Reshma and I have been working on to like the community partner stuff. But it's going to be a really cool conference. There's going to be all level of talks, but this will be a really good, I think, ground-based. And if you're interested in learning more, you can definitely do that. We also, as part of Nodes 2020, which isn't really necessarily on the site, we do have certified developer, like Neo4j certified professionals training, like advanced level training. It might be like, I highly doubt that like after this thing, you guys will be like ready to get a certification. But if you do get your certification, which is free and you can take as many times as you want, you'll get access to the advanced level trainings that are 2 weeks leading up to Nodes 2020. So, you know, I'll also add a link for the certification. Yeah. And is there anything else we want to say? Reshma, I'm going to let you take a lot of this stuff away from me. I don't need to.
Sure. I just shared the link to my blog because I was introduced to it and then I was hooked on it. The other thing that I want to say is questions. If you have any questions, feel free to ask. There's a Q&A tab that you can put questions in there. If you happen to post the questions in the chat, it's fine. I can just move them over to the Q&A. Feel free to ask. We're all going to be online. And this is being recorded, so you know, we'll send you a link afterwards. I think that's all I can think of.
And you said you wanted the Q&A questions in the Q&A section?
Yeah.
Okay, so guys, just if you don't know how to navigate Big Marker yet, when you post a question in the regular chat, there's a little, like there's a send button, right? But underneath it, there's a little thing that says add to Q&A. You can actually add that question to the Q&A, or you can click on the proper tab at the top of the chat that says Q&A. Please post your questions in Q&A there. That way other people can vote them up. We can click when they're answered and all that fun stuff. And I think that's good, right? So should we start recording? Lou, you might have to like just give a quick rundown of what we're going to be talking about today once I start recording.
Yep, of course.
All right, cool. So I'm going to start recording now. Let's see. Wait, I think I did. Yes, recording.
Cool. Hello, everybody. Welcome. Thank you very much for joining us today. We are going to be going through an introduction to Neo4j, a graph database, the most popular graph database, and it's going to be a whirlwind fun journey we're going to be doing. We are going to be coding along as well, so there is a lot to be learned. So a quick introduction. I am Lou Lazarevic. I am a developer relations advocate here at Neo4j. If you need to get in contact with me, you've got my details on the slide, and I will have them at the end of the pack as well. And quickly, what I would point to you to is we have a fantastic community. So you've got the address there, community.neo4j.com. Please come along, join us. If you're an experienced Neo4j user, if you're completely brand new and never used Neo4j before, you are welcome. We're a friendly bunch. We have an amazing community who come and answer questions that you have, and it doesn't matter what that question is. We have got a lot of learnings there as well. We have our knowledge base there. Any new announcements about the product, that all comes there. So do come along, be friendly, don't be shy, come say hello. So those are the details there. And let's get cracking in this session. So what we're going to be covering today, I'm going to cover what is a graph, very quickly, you know, what is the origins of graph and why do we need them? And then we're going to increment from there and start having a look at different ways you can start spotting where it could make sense to use a graph in problems that you might be looking to solve. We will then have a look at the anatomy of a graph database, specifically a property graph database. Don't worry, I'm going to explain what that means. And also, we're going to start touching on Cypher, which is a graph querying language that we use with Neo4j. And then we are all going to have a go. We are all going to have a code along where we're going to be working with the movie graph database, which is available on the sandbox. And I'm going to tell you a little bit about the sandbox when we get there. So don't worry, you don't need to download anything. You don't need to install anything. It's really, really quick. And we're going to be doing that all together. And for those of you who are super keen and eager, you've got the address there. So what you can do is if you want to sort out your login, if you want to get, authorized, authenticated, that kind of thing, that's available there. If you're keen, don't worry, we'll have time as we progress through the talk to do that. And then last but not least, hopefully we have whet your appetite and you're going to be really excited and want to learn more. So we're going to cover some various bits and pieces that you can look at. So what resources are available so that you can continue your graph journey. And yes, when questions come in, yes, we do have a Slack workspace. So we do have a Neo4j user workspace, and we'll try and get the link up for you in the Q&A. Okay, so let's get started. And again, if you've got any questions, do pop them into the Q&A. I'll be keeping an eye on that. And what we'll do is, as it makes sense through the talk, I will pick up on that question and mention it. And again, this works as well for when we're doing the hands-on component. So first of all, what is a graph? Very commonly, especially for those of you who have never come across this before, or your sort of college level maths is a long distance memory. When we talk about graphs, we're not thinking about charts we might see in Excel or something like that. When we talk about graphs, what we're talking about is a set of discrete objects, and these discrete objects have some kind of relationship with each other. So that is a graph. So that is a mathematical practice, and it's basically this idea of having entities and understanding how those entities are connected to each other. So this originally came from, or graph theory originally came from, this maths problem. So there's this city, Königsberg, so it's now Kaliningrad, modern day Kaliningrad in Russia, so it was in then Prussia. And this town, Königsberg, they had 4 land masses. So they had the sort of the north land mass and the south land mass, and they had sort of an island and a split, and they had this river splitting through them, River Pregel. And they had 7 bridges that allowed you to access the various land masses. And the interesting challenge here, they had a look at it, and somebody thought, well, actually, is it possible for me to go across every single bridge in Königsberg and visit all of the land masses? But the kicker is you can only cross over the bridges once and only once. So you can't go over a bridge more than once, but you have to go across every single one. And this was wrapped up into a maths problem, maths challenge put into a newspaper, and very famous mathematician Leonhard Euler came across this. And this piqued his interest, and he went away to try and solve this problem. And effectively what he did was he recognized that he could take these land masses and he could take the bridges and he could simplify this down. And effectively what he did was he simplified down the bridges, the different routes you could connect, as the relationships, the connections to the 4 land masses. So the 4 land masses in this example are the entities, and the bridges, these lines that we have here, these are the relationships that are showing how the land masses are connected. So effectively, he took this problem, he simplified it, and therefore graph theory was born. So that's a graph. It is the relationship between entities, so how entities are connected. And as such, an entity can exist without a relationship, but a relationship cannot exist without entities. And absolutely anything can be a graph. For example, the internet can be a graph. And there's lots of different ways how the internet can be a graph. So we may think about how we're connected to each other and how we're communicating to each other. So maybe we're sending emails to each other. So maybe we're going to show how 2 people are connected by an email that was sent. Maybe they have a Skype call Maybe there's a group of people on a Zoom meeting, so maybe we're going to be representing all of the different people who are connected because they're on a Zoom call, or this webinar indeed. Or maybe we're looking at how messages are being sent. But also we can represent the internet as a graph if we start thinking about the components that make the internet. So we're going to be looking at the computers that are going to be connected to some kind of cabling. Maybe they're now connecting to routers, either wired or Wi-Fi routers. Maybe we're now starting to look at the various servers and routers and load balancers down to the tin. We can start to think about how all of these different things are connected in this graph. So we're looking at the entities, so the devices or the people, and the connections that join them together. Let's show how they're related. A water molecule can also be a graph. And if you think about the chemical composition of a water molecule, right, you can have, you have your two hydrogen atoms and your oxygen atom. But the thing that makes it a water molecule is how those elements are connected. And that is this idea of having the configuration in a certain way, so that the hydrogen atoms have to be connected directly to the oxygen atom. They're not connected to each other. So that is a representation of a graph. And one question has come up: can a linked list be considered a graph too? Absolutely. And why not? Because you're thinking about the series, about how different elements are connected. Now, you may not necessarily want to represent all linked lists in a graph, but theoretically, yes. When you think about what a linked list is, and you think about what you're interested in is, for example, if you're representing state in a linked list, you're going to be interested about how the previous state is connected to the next state, and how the next state may be connected to a future state. So absolutely, there is, your entities that are connected together, and you want to understand how they're being related. So why do we need graphs? Why are graphs really important? Why do I think they're so brilliant? So I'm going to work through a very silly example here, but I think it takes the story. If we think about when we're trying to solve problems, when we're trying to think about how we store data, how we're going to access that data, how we're going to query it. If we think about, well, here's a real life problem that we're looking to solve, and we're using technology to help us solve it. Usually, if we've got a problem, it's best understood with a representation of reality. And let's look at this example here. So we've got somebody who sat at a cafe drinking a coffee. And when we start thinking about, well, how do we explain, this scenario that we're looking at, or this problem we're trying to solve? Inevitably, we're going to start drawing some pictures. And inevitably, it's going to be about how things are connected to other things. So you see this graphy theme coming in. And this example here, we want to represent that we've got a person who's got a coffee, and the relationship between that person and coffee is that they're drinking it, and they're drinking it in the cafe. And if you think about some of your more traditional approaches about how you'd go about capturing that information, you could well, for example, be using a tabular database. So you may be using a relational database, for example. And when you're thinking about how you're mapping it, you're going to go do some normal you're going to be thinking about the data, and inevitably describely representing what we see. For example, here, somebody drinking a coffee. And it gets further still. And if you think about some of the really large data sets that you might be working with, you may have dedicated databases. So if this was a huge campaign to have a look at how millions of customers worldwide are consuming coffee at a big chain, then we could easily be having separate databases storing this data. We have these silos. And again, this idea of the reality of the problem we're trying to solve doesn't stop at these containers. We want to look at how these things are connected to each other. And this is where graphs step in, because it provides this better approximation of reality. And you can kind of see the image that we've got here in the middle is very similar to this thing that we would doodle to try and describe what's going on when we're describing this problem we're trying to solve, or what we're trying to represent. And what I want to do to just sort of keep exaggerating this idea of how we can represent reality and how things are joined together, I'm going to give an example of buying trainers. So we've got an example here, buying trainers. We're going to follow the flow. So I'm going to slowly introducing you into some graphs here. So it's all good, it's all gentle. And here we've got in the middle, we have this product node and this product entity, and it's trainers. So we know it's a type product. It's trainers. Those trainers have a price. And if we have a look, we have 3 entities with a person label. And what's interesting here is if we have a look at how they relate to products, so we see that these 3 people have bought these trainers. And if we have a little bit further at the property, we can see that they've been bought at different dates. And we can see that Jane, then Alison, then Ian bought these trainers. So I think there's a little bit more. And in this conceptual example, let's think about how we'd be adding some data sources to this to try and tell a bit of a story. Is there some kind of relationship going on here? So it turns out Jane buys these trainers and she's very happy with these trainers. So she sends a message on Twitter. So she sends a tweet out saying, "I love my trainers." And it turns out that Alison follows Jane on Twitter and she reads the tweet, and that's influenced her to go and buy these trainers. You know, Jane's been very positive about those trainers, so she goes and buys them as well. It turns out Alison also is impressed with these trainers. So she goes and posts an update on Facebook. "My trainers are brilliant." It turns out that Ian is friends with Alison on Facebook, and Ian sees this update that Alison's posted, and that goes on and influences him to buy these trainers. And he then goes off and posts a picture of them on Instagram and so forth. So you start to get an idea of how we can start following the flow, because we're capturing these different entities, you know, what's going on, how people are interacting, or the messages that people are posting, or how information is being shared. And we're being able to connect these things up so we can understand this story of what's happening, what's driving this thinking. I'm going to pick another quick example. So this is very famous. Again, this would be a great poll to see how many people on here have come across either the Panama Papers or the Paradise Papers or the Swiss leaks. So they all use exactly the same data model. But again, they're all using graphs. So I'm going to quickly talk through this data model. So effectively, we've got 3 different types of the same entity. So we've got an officer. So this could be an officer of a company. So this could be a person. There could be a director. There could be an employee. There could be an owner. We've got an entity, and an entity could either be a company or it could be a company owner. So you know how a company can own another company. And then we've got an intermediary. So an intermediary could be an intermediary company or an intermediary person. So like they're acting on behalf of a company or carrying out some instructions. And if I just quickly talk through what's going on here, and then this is effectively how the Panama Papers, this is effectively the data model I used for the Panama Papers. And the really cool thing here is what we're capturing is how are people or companies connected to each other. And they could be connected to each other because maybe a person owns a company, or a company owns another company, or a person is a director of a company, or a person is an intermediary of a company, or a person is a shareholder of a company. So we're connecting them. So we're doing each link. And as soon as we discover that a person is a director of company ABC, we put that connection in. We know they're connected. And then we go, well, okay, this person then was also another owner of company XYZ. So we put that connection in. And then that company XYZ owns a significant proportion of company EDF, and so forth. And we keep going through, and we keep connecting these. And then we're adding information like registered address. And effectively what we're doing, you think about it like a chain of Christmas lights. So every time we know something's connected, we join them on. And then if we want to find out whether somebody is offshoring their accounts or trying to minimize their tax obligations or things like that through going for a number of companies, because these things are connected, and each time we knew these things were connected, we put in that relationship. Then it's like a Christmas light. You start at one end, you just follow the lights through to the other end. And this is why the Panama Papers were so powerful, because you had a large number of individuals who thought, because we're hiding away how we are connected to different things and we're burying it in paperwork, in a traditional tabular system where we look at data, it would be quite hard to track these connections down. But because the whole nature of graphs is about understanding and exploring these connections, suddenly it becomes really, really easy to see whether somebody has a connection with a Panamanian law firm or companies being managed. And this is how we saw a large number of people in power around the world get discovered with their activities via the Panama Papers. And again, a quick plug for the sandbox. We do have the Panama paper example up there. So if you want to have a go with some of the data in there and explore, you will have that option there. So you have that in the sandbox. And last but not least, and this is a little bit related to what we're going to be doing later when we do hands-on code, is this idea of understanding friends of friends. So again, this is really powerful, because what we can start to do is based on people knowing each other. So let's say, for example, I am friends with Anne, Dan, and Jane, and somebody called Bob is also friends with Anne, Dan, and Jane. And what we can start to say is, well, because we both have the same, we have the same common set of friends, then there's a likelihood that Bob and I know each other. And if you think about on Facebook or LinkedIn, when they start to suggest friends, they're looking at mutual friends. So this is where we're using these relationships to then predict where there may be other relationships that have not yet been discovered. And I'll talk about friends of friends here. And the example that we're going to be looking at in a bit is going to be co-actors of co-actors. So I've got a quick question. Can we define multiple connections between two unique objects? Absolutely. So you can have more than one relationship between two entities. So let's, as a quick example, and we'll have one when we're looking at the graph. So let's say we've got Jane owns a car. So you have Jane as an entity and car as an entity, and you have a owns relationship between them. But you may also want to capture that Jane drives that car as well. And there could be reasons where you have more than one relationship that describes how the two entities connect. So absolutely, you can have more than one relationship between entities. So let's quickly, before we start diving into the anatomy of a graph database and looking at the query language, I'm going to go through some generic examples of where you might spot graphs in the problems that you're looking to solve. So this is just very high level. So identifying the good graph scenarios. So one might be, are you trying to understand the relationship between entities? So this is very similar to the Panama Papers example that we just looked at, and the trainers one as well. So for example, let's have a look at how people are interacting with the product. So we've got two customers here, Lisa and Jane, and they both buy t-shirts. Now, whilst those t-shirts that they buy are different, so one's a red t-shirt, one's a blue t-shirt, they both come under the category of t-shirt. And we may want to understand the relationship that people are buying t-shirts, because if they're buying t-shirts in combination with other things as well, so for example, if Lisa is also buying sunglasses, shorts, and a baseball cap, and Jane buys a shorts and a baseball cap, we may want to recommend sunglasses as well, because they're following similar patterns. So anything where you may be wanting to do recommendations, so we could be recommending what product to suggest, we may be recommending what film you might want to watch next based on what other people are doing. This is a good example of a good graph scenario. Fraud detection. So again, this idea of, is there a group of people who are sharing the same personal details? Maybe they're sharing a phone number or an address and different things, where we're wanting to understand those relationships. Finding duplicates. So people accidentally put their middle name and their first name the wrong way in the system, and you've got lots of the customer, you just want to make sure you've got the same customer boiled down. And data lineage. You want to understand where your data is being used across the system and how it's being manipulated. Another example of a good graph scenario is, do you find yourself referring back to the same type of entity? So let's look at this example here. So here we've got a company hierarchy. So we've got Jane. So Jane's an employee, and we want to understand all of the direct and indirect reports that Jane has. So we have this referencing of how employees connected to employees connected to employee. So this kind of self-referencing. And this is a great example of something that works well with graphs. So especially where you want to just run down the connections rather than having to keep looking up over and over again who's connected to who. So anything where you're looking at organizational hierarchies, access management. So if you want to understand who's got permissions to access which files or who's working with a project, really great for that. Social influencers. So we had an example where we looked at trainers. So are some people more connected than other people? So you think in Twitter, where you may have large groups of people connected or following one person, they can be quite influential in their network. So can you spot those influencers for either promoting a product, or you want to understand, what impact they have with bringing friends and family to a particular service? And friends of friends. So we touched on a quick example where we can try and predict who might know who based on common friends or common locations and that kind of thing. And quickly go through scenarios. Another one would be, do we want to explore things of unknown depth? So for example, a supply chain. So a supply chain can have many, many layers. So you think about that cup of coffee that we were, we described in our initial example of representing reality. So when you buy a cup of coffee in a cafe, you think about the huge number of organizations that were involved. So you've got the shop itself where you bought the coffee. They're going to be buying the container that coffee's stored in. Are you having that coffee with milk? So, okay, that milk's going to have come from a reseller, that will have come from an even bigger reseller, that would have come from a farm somewhere. The coffee beans itself, those would have been bought from a distributor, which have been bought from a bigger company that has the coffee beans, that will have interfaced with the farmer. The farmer's going to be dependent on seasons and that kind of thing. So you can get this feeling of all these varying depths where it's not always obvious to predict how far deep you need to go. So again, really great graph problem because all of these entities are connected and we're exploring those relationships. So again, you might use it for supply chain visibility. Bill of materials, when you're building a laptop or buying a car, you're going to have dependencies on what wheels you can add to your car or what extras based on other dependencies. And network management. So you think about things like your home network or the internet, where if a router goes down, what impact does that have on the rest of the network? And last but not least, are we looking at lots of different routes or paths? So as an example here, graphs are very popular for route planning. So as a quick example here in the UK, if I'm in London and I want to go up to Edinburgh, I've got one of two ways I can go. I can either go up the East Coast, and up the East Coast I will go past York and Newcastle, or I can go up the West Coast where I go past Rugby, Crewe and Lancaster as an example. And we can use graphs to help us figure out the most optimal routes for how to get there, either based on cost. So let's say we want to get the cheapest train ticket to get us up there. So for example, going up the West Coast takes longer, but the tickets can be cheaper, or by speed. So we want to get there as quickly as possible based on miles and so forth. So again, this is quite common if you're looking at logistics and routing. There is a really great video, I think it's on Vimeo, I'm not sure, of where we've got an eBay shuttle where we had somebody from Shuttle present at Graph Connect, and they used Neo4j for their route planning, and they ordered a whiskey at the start of the session, and the whiskey arrived at the 30 minutes later at the end of the session. That's great fun. Infrastructure management. So again, this idea of understanding what's the most efficient way to route your communications network, and dependency tracing. So again, back to this idea of the router. So if the router goes down, how does that impact the rest of the network? So that's enough of that. So that's just to give you some hints about how you can start equipping yourself to spot these opportunities where a graph is a good fit. Let's have a look at the anatomy of a graph. So we've talked about the theory. So let's have a look at the anatomy, and then I'm going to come back to some of your questions shortly. So we talked about our entities and how they're connected. So the main graph components that we have are the nodes or vertex. So if you're in a graph using graph theory, they're referred to as vertices, we call them nodes, and these are our main data elements from which the graphs are constructed. So these are our entities, these are our topics that we're looking at. So in this example here, we've got one that's been labeled Jane and one that's been labeled Carl. And then we have the thing that connects them, which is the relationship, or edge, can be referred to again in graph theory. And this link that connects them can have a direction. So in Neo4j, we write the direction. So you have a direction. So it says, what is the relationship between the two items? And we have a relationship type. So what is that relationship between, in this example, Jane and Carl? And as I mentioned before, you can have more than one relationship between the entities where it makes sense. And as I mentioned before, you can have nodes and no relationships, that's fine. But a relationship cannot exist if there are no nodes with which to connect it to. And Neo4j is what we call a property or a label property graph database. So as well as having the node and the relationship that we've mentioned, we also have some other things as well. And what we've got is a label. And a label is a really great way of being able to categorize what our nodes are. So what do they do? And this example here, we've got one for person. So we've got one node that's got a category of person, and we've got another node here that's got a category of car. And we can have more than one label. So there can be very good situations where we need to have more than one label on a node. So here we've got an example of a person owning a car. Maybe we want to talk about assets as well. So maybe if we were looking at insurance, and you're going to have many assets. Your car's going to be an asset. Maybe you've got an expensive television or a laptop. Maybe you want to count your house as well as an asset. So you may want to tag these in a different way. And this is a really great way of being able to quickly search and group the nodes. And we can have properties as well. And we can have these properties on both the node and the relationship. And we've seen some examples as we've been going through. And this gives us the opportunity to enrich our nodes and relationships. So in this example here, we are saying that person has a property type of name with the value Jane. So you can start seeing how we can have different nodes, different person nodes with different names. And here we've got a couple of properties on the car node. So we're saying that it has a make, which is Volvo, and the model V60. And we can also attribute the relationship as well. So we can say, well, when did that owns relationship start from? In this example here, Jane has owned the Volvo since 2018. So quick questions asked. Examples of where a node can exist without a relationship. So you can have orphan nodes, and there may be a number of reasons why you have them. So it could be that you're loading data, and then the second pass will be to connect the nodes up. Another reason can be is that you find some data, and you don't yet know how that data is connected. So let's say, for example, you're pulling in some customer data. So let's say you're pulling in a big database of products that you have and customers. And it could well be that you've got some customers on your database. So let's say somebody's registered for your, to your company, but they've never purchased anything, and you just keep them as separate. So those could be orphan nodes. And then at some point in the future, when they buy a product or when you discover some more information, then you connect them up. So absolutely, you can have that scenario. Somebody's quick task, is a node synonymous to a row in a relational database? More or less, yes. So as with when you're thinking about designing a relational database, and you're thinking about what information you're going to have with regards to sort of column names within your database, and you have the rows, you have a similar idea as well. And again, obviously, dependent on the question that you're asking, and this is true irrespective of what data storage system that you're using. As a very similar example, you could have a situation where the row would be the properties that you have. So each of the items you have in your row would be the properties for your node, and a row could be a node in a graph database. Okay, and quickly check a couple other questions we've got. Is it fair to say a graph database is better than a traditional database where there is direction associated with the connections? So a quick thing about directions with connections. So the general rule will be, if you are looking at connected data, look at a graph. especially if you've got many connections, you should see a significantly faster performance when you're using a graph database, because a graph database is all about looking at the connections in your data, whereas tabular data is really great for running through a table and doing any summations or calculations on that data. So definitely around that. With regards to directions, so the thing with directions is you can choose to use them. So if directions are really important in your data, and again, you'll have data models describe that, you can use that within the graph database. So you always have to provide a direction for your relationship when you're writing the data in Neo4j. But if you don't care about the direction, then you can ignore the direction when you're doing your read processes. But if you do care about them, then you can still use them. So yes, the direction you can use as you see fit within the graph database. And a quick question we've had, can graphs be used for identifying false positives in case of fraud detection? I'm not sure I fully understand that question, but what I will say is there is a lot of content about using graphs and fraud detection, and you can use it for things like based on the business rules that you provide. So if you've got certain criteria where you say, I want to raise the alarm, I want to investigate this case, when, for example, X number of common details are being used, or a name comes up, or there's a succession of transactions within a certain area, then you can set those business rules. But again, it's going to be the same with any case you're investigating it, where your business rules are going to drive what is your threshold for determining, say, fraud in this example. Okay, so let's continue. So what I'm going to do now is I'm going to touch on Cypher, which is the query language we use in Neo4j. So this is getting you set up slowly for when we're going to have a go at coding ourselves. And a little bit about Cypher. So Cypher is a pattern matching query language made for graphs. And you will see what we mean by the pattern matching. It is a declarative language. So what do I mean by declarative? Is you can have an is with the declarative language, you don't have to tell something how it's going to do an instruction. So if I give you an example, if I ask a colleague to tell me, is it raining outside? I could give them a set of instructions. I could tell them, well, actually, I want you to walk to the window. I want you to open the window. I want you to stick your head outside and have a look for raindrops and to check whether the ground is wet. So that is like providing an imperative here. But actually, with the declarative language, I could say to my colleague, as an example, is it raining outside? And then it is up to my colleague to decide what is the best way to check whether it's raining outside. They may decide to go and look out the window. They may decide to go check on the weather forecast. So there may be a number of ways that they can do that. And by going down the declarative route, I just ask what I want. I ask the question, and then the engine, so the query engine here in Cypher, will then decide what is the best way to answer that question. It is an expressive language. So what you will see is as we start writing these queries, the queries are very representative of the questions that we're looking to answer. And it's pattern matching. So you will spot to see it's very formulaic about how we declare what labels we're interested in, what relationship types we're interested in, and so forth. So I had a quick question here about working with Neo4j, communication with Python. So you have a number of options of working with Python and Neo4j. So we do have an official Python driver, so that's one way. And again, there will be many examples of using, for example, if you like using your notebooks, or if you like using Jupyter or Zeppelin, and using that with the drivers and working with Neo4j. And there's also very good community Python Neo4j driver. So yes, there are plenty of examples of using Python with Neo4j, and you can literally, in some examples, write your Cypher statements and you execute them, and then you manipulate them in your notebook. And another question here about examples of data sets that shouldn't be stored in a graph database. So again, this is very much going to be driven around your decision. So the pushing, anything where you are looking at millions of rows, and let's say you're wanting to work out the average salary, the average salary of all of Hollywood, which is a great example of that my colleague Max Damazi uses, or you wanted to work out the average height of all of your Hollywood actors over the past 50 years, that's a great example of something you would do in a tabular database. Again, you think about it, you'd have in your table, one of your column headings would be height, and you would just take that entire column, work out the average, and that's super fast to do that in a relational database. Whereas if you're doing it in a graph database, you have to look up every single person node that's got height, pull out that property and work out the average. So you can do it, but it's more efficient to do that kind of thing in a tabular database. Whereas if I wanted to know how the 50 actors, how the actors of Hollywood are connected over the 50 years and do like Kevin Bacon number, then that's a great graph problem because we're looking at how people are connected. And so that's an example. So anything where we're looking at big numbers and we want to do like averages, when you'd have like one column you'd be charging down on the table, that's an example of something you probably wouldn't want to be doing in the graph database. If you're not looking at huge numbers and the graph database is your primary source, then sure, you can still do that query. But if you're using polyglot persistence and you're picking the right database for the right job, then you wouldn't necessarily do that. And okay, cool. So let's continue. Oh yes, we use ASCII art. This is the best bit in my opinion. I love the fact that we use ASCII art in Cypher. So what I'm going to do now is I'm going to step through some of the basic commands with Cypher. So hopefully when we start doing our hands-on example, you're going to go, aha, I know what I'm doing here. So we're going to talk through the queries as well in the example, but this is just getting you warmed up. Okay, so we use match to retrieve nodes. And so much like you have select in SQL, we use match in Cypher. And if I wanted to retrieve every single node in my database and return them, what I would do is match n. And what you'll notice here, we have the round brackets. So round brackets represent nodes. So here we want to match n, and here n is a variable name. So this is our little placeholder. So this is the container that we're saying when you run this, run this portion of the query, please save all the references into this handy pointer. It's called n here. You can call it whatever you like. I'm just using n here, n for node. So match n, return n. So that's then going to return everything that we have. I've got a quick question here. Does it work with Quarkus or Spring Boot? So yes, we do have Spring for Neo4j. I'll see if I can pull out a link for that. If not, if you just search Spring Neo4j, you will get the various links and libraries for that. Okay, so moving on, we're expanding out the match example here. So if I wanted to bring back all of the nodes that are of category person, so we've got the person label applied, then what I would do is I use this convention of colon person. And so here everything to the left of the colon. So if that's left to the colon in a node or left to the colon of a relationship, we'll show relationships in a second. That's our variable. That's our container, our placeholder that's going to hold the result. And then colon, and then the keyword is going to describe either the label or the relationship type. So here it's person. So this is going to match all of the nodes that have the label person, and then we're going to return all of those person labeled nodes. If I want to get even more specific and say, well, actually, I want to return all nodes, so I've got a person label attached to it, and it has a property name, a property type of name with the value Tom Hanks. So I want to bring back all nodes that are person with the name Tom Hanks. Then what I would do is same convention. So here's our placeholder that we're going to hold the results. Here is our label, colon person. And then I use the curly braces to refer to any properties. So here we have name. So it's always, we use this key value format. So the key to our property here is name, and the value is Tom Hanks in quotes, and the return n. And that's going to return all of our Tom Hanks nodes. So what we're doing here, what we've just described, is we're inlining the property. So this works only when it's an exact match. And there's a question here as well, is Cypher case sensitive? It depends. We'll come back to that in a second. I've got a slide on that. So certain bits are case sensitive. So labels are case sensitive. So here we can return all of these Tom Hanks nodes that I've got the label person, but it only works with exact matches. What we can do is say, well, actually, and I know I've got the equivalent example here, but if I just want to find Toms, and we do an example of this in the hands-on, what I can do is use a where clause. So similar to what you'd have in SQL. So we're matching P person. So again, I'm using a different placeholder name. Same idea, still a placeholder. It's to the left of the colon. So match P person. So match all of my nodes that have the person label on it. Where, and now we can access the property where p.name. So where I'm pointing to my variable here, dot name property equals Tom Hanks. Return P, and this is going to return, and that does exactly the same as the statement here. But what we can do here is we can now do range queries as well, and we have an example of that shortly. So if I wanted to do my range query and say, well, actually, what I want to find all movies, so I want to find all nodes with the movie label, and I only want movies that were released between 1991 and 1999. So same idea, match movie. So all of the nodes that have a movie label, where the release date. So these nodes have got a release property on there. So where m.released is greater than 1990 and m.released is less than 2000, return all of those nodes. So that's using match. Now we're going to extend the match. So now what we're going to do is we're going to start including relationships as well as the nodes. So as a quick visual example here, this is an example of what we're looking at. So here we've got a person node, our Tom Hanks, our hero. You've been using our first examples. And then we can see, well, we've got two different types of relationships coming out of, from here as an example. So we've got an example of where Tom Hanks has directed a movie. So this is our movie node with some details. And we've got an example of where Tom Hanks has acted in a movie. So here, Apollo 13. And if we have a look here, we've got Kevin Bacon. And you've got Kevin Bacon has acted in the movie. So the same movie that Tom Hanks has. So let's start having a look. So if we wanted to find out, if we wanted to ask the question, find all of the movies that Tom Hanks has acted in, we would do this. So we've got this. This is all familiar. We've done this before. So we're matching all of the person nodes that have the name Tom Hanks. And then what you'll see here is we represent relationships as an arrow. So we could do 2 hyphens and then the direction of arrow if it's relevant. So we could have done this without the arrow. And if we want to specify any specific details about the relationship, so here we want to specify the acted in relationship, because that was our question. We wanted to know about what movies Tom Hanks has acted in. Then we do this similar convention as we did with the node label with the relationship type. So colon, acted in, and then movie. And notice the only placeholder, the container to store our results we've put in is in for movie, because what we want are the movie titles. So here we just put it in for that, and then we're doing return m.title. And this will give us a list of results. So we can specify just a specific property that we want to return. If we wanted to find out all of the movies that Tom Hanks has directed, and we want to order it by the newest movie, so we do exactly the same as what we've done before, except we're interested in directed rather than acted. So you see we've changed our relationship type. And then what we do, m.title, and similar convention to what we would do in SQL, we've got m.released, and we're ordered by m.released descending. So by default, if we order by something, it'll order it ascending. Now, if I wanted to find out all of the co-actors that Tom Hanks has worked with, so we're now starting to touch on to the next node, I would do this query. So again, same idea with oops, get Google Slide Manager come out of the way. So the first part of the query, we're familiar. That's going to find our Tom Hanks node. We're then going to traverse, and notice I don't have the box anymore. That's because I want to know any kind of interaction that Tom Hanks has had. So that'll do any relationship that comes off of the Tom Hanks node to movie. And then we come back again. So we want to find all of the co-actors. So this is where we will specify the acted in relationship. co-actors person. So again, look, we've got our container of variable that's going to helpfully hold our result, which is called co-actor, and then we return co-actor.name. And we're going to be having a go at this shortly. And just quickly touching on when we're creating nodes. So if we wanted to create a Tom Hanks node rather than matching it and finding it, then we just change the language. So whereas before we had match, we've just swapped match to create. So here, what we will do is we're going to create a node with the label person that's going to have a property key of name and a property value of Tom Hanks. And we're going to assign it to that variable, that container P. So if we want to do something more with it. If I wanted to match Tom Hanks and I wanted to match the movie Apollo 13, and I wanted to create a relationship between those two items, so to say that Tom Hanks acted in that movie, then I would do the match. I find my two anchor points that I'm interested in. So my start point, which is going to be the person node, my end point, which is going to be that movie node, and then I do create. So using those variables, those placeholders that we use to store the result of that query, I'm going to do create. So here's our reference to our Tom Hanks node that we're storing in P. Here's our reference to our movie node being stored in M. And then the acting relationships. And see here, we have to specify the relationship type and direction because we are creating the relationship. Now, what we could do, if we wanted to be super fast, then we go, well, a Tom Hanks node doesn't exist, a movie node doesn't exist, and the relationship that Tom Hanks acted in that movie also doesn't exist. Then what we could do is write that whole pattern. Now, bear in mind, that will create the entire pattern, nodes and all. So this is when we start talking about patterns. So anything to the right of our create to our match, that is our pattern, and it will try to do that. So I've got a question. Do we need to explicitly create relationships each time? Yes. So where you know there's a relationship between two items, you need to create a relationship. But what I will say is you do automate a lot of that. So when you're doing a data load, much like you think about you've got a mapping table in a relational database, you will have some kind of a mapping. So you can very quickly, when you're doing ingests of data, either if you're loading from a flat file or you're doing some kind of offline, or even if you're codifying it, you can speed it up. Obviously, it'd be painful if we were hand coding each of these, but when you're actually coming to loading sizable amounts of data, there are very quick ways of doing that. But again, what we can use graphs, there are things we can do to infer relationships afterwards, but that's not for the topic of this conversation. So I've got an example here of the create. So, oops, I don't have that slide. So I'm going to quickly mention about code case sensitivity. So we have the convention that we use for writing our Cypher and the case sensitive stuff. So the convention is anything like create, match, as, order by. We have that in uppercase. And then we have the case sensitivity stuff. So anything that's a label. So here, this is case sensitive. If I did this with a little p, Neo4j would assume, or Cypher would assume I'm looking for another kind of label that's spelt with person lowercase. Same with relationship type. This is case sensitive. So if you change it, it will not work. So that is also case sensitive. If I start off with a lowercase p as my placeholder, my variable, if I change that to capital P, it won't work. So that has to stay consistent. So that's case sensitive. The label is case sensitive. Properties are case sensitive. So property keys are case sensitive. And also strings here are going to be case sensitive, as one would expect. So those are case sensitive. And then everything else is by convention. Okay, right. It is now time to have a go. And we're going to be doing it together. So as I said, you have got the sticky at the top. So if you click on the blue sticky, that should be working, and that's going to direct you straight to the blank sandbox. Otherwise, you can put in the address sandbox.neo4j.com, and that will get you there. So if you've not already done so, you will need to sign in, and you've got a couple of options there. You can either use your social media credentials. You've got Google, I think you've got Facebook in there as well. If you don't want to use your social media credentials, you can use a username and password. So you can just sign up and set that in. Okay, so you've got a question between what's the difference between hyphen and the arrow. So if we use the arrowhead is saying we care about the direction when we're doing our query. If we don't use the arrowhead, it says we don't care about the direction. So that is it. And you can have a play with that when we go into the sandbox. And I'll show you when we go through that.
Lou, can you hear me?
Oh, I can hear you, yes.
There's more questions. They're in the published tab. So we didn't realize that, like, when people post questions for the admin side, it just shows it in the new category. So if you click on published.
Right. Okay. I will go through those as we get the sandbox spun up then.
Cool. All right. Thank you. I just wanted to make sure you saw them because they were.
Yeah. So I was answering the ones as they're coming in the new section.
All right. Cool. Yeah, I saw that. So I just wanted to make sure you saw those. Okay.
Perfect. Right. Okay. So we are going to have a go together. So please do go to the Sandbox website if you're joining in. Please do. It's super good, and this is a really great example because you can have a go in your own time afterwards. So we're going to do it together. It might be a little bit at pace depending on how time goes, but then you can do this. It's easily accessible, and you can have a go at your own leisure as well, or if you want to have a rethink through things and see what's going on. So we're going to go over to the Sandbox. So I'm going to assume you're signed in. I'm going to give you a few moments as well to get signed in. And if you've not been directed automatically to the blank sandbox, to start up the blank sandbox, we click on New Project. And then I've got an option here of blank sandbox, which is what I'm going to select. And I'm going to launch that project. And then that's going to go and get set up in the background. So we shall let you do that as well. So I'll give that a couple of minutes. And let's have a look at some of the questions that we have. So are all caps required, or is it like SQL where it's in the stand method? Yes. So as we covered some things, it's just convention. So things like match, create, ordered by, as. You'll see some examples when we work on the sample data set. That's convention. But there are things that are case sensitive. So our node labels are case sensitive. Our relationship types are case sensitive. Our property keys are case sensitive. And any variables that we use are case sensitive, but everything else is convention. And can you please talk about how data needs to be structured and uploaded for graph databases? So what we'll do is we'll have a quick look at the data model for the graph database, and please hang around because at the end I have some information for you with regards to how to continue your graph journey. And we have loads of amazing training material. We've got developer guides, and I all go into this detail about how do you start, not only how do you go about creating a graph data model, but also how do you take something. So if you've already got something in, say, a relational, your relational data model, how can you start porting that into a graph data model? So we have a lot of stuff around that. So do keep an eye out at the end. We will cover the further materials available. And another question we've got, if a relationship is skipped, like in the last Tom Hanks example, does that mean all relationships I acted in as well as directed? Yes. So because we didn't specify a relationship type, then it's every single where we specified the area. So we've got an outbound relationship there. Every single outbound relationship coming from the Tom Hanks node will be used in that pattern. So that's really good if we just want to find out how people are connected, and we don't care how they're connected. We just want to know that they're connected. Okay. So hopefully we are almost ready. So I'm going to go by how long my one takes to assume that everybody else is in a similar place. And then once it's spun up, I'm just going to give you a quick tour of Sandbox. So you'll notice we're not having to download anything. We're not having to install anything. This is sort of like a clouds play area to work with the database. And as you may have spotted for those of you who clicked on new project, you've got loads of other things to look at as well. So you've got the, you've got the Panama Papers there for those of you who want to have a look at that. You've got examples if you want to import your Twitter data and explore that. You've got that as well. We've got a fraud example. We've got a graph data science example. So good stuff there. Do have a look and explore that. Okay, I suspect this is already loaded. I'm just going to quickly give that a quick reload. So can a label be numerical format? For example, I talked to a friend 4 times. So that's a great question. So this is starting to look at what modeling decisions we make based on the questions we want to ask. So, and again, this is very much going to be driven what kind of question you're looking to answer. So if you wanted to optimize for speed, and so when you're doing a query, if you specify a label, you can very quickly filter out all nodes based by labels. That's one of the fastest actions you can do. And if you wanted to do, for example, count the number of friends that you spoke to 4 times, then you could, for example, there are cheaty ways which I'm not going to cover, but you can have a number in your label, and that's fine. But what you may decide to do, actually what makes more sense is you want to have a property on your relationship. So let's say Nyabiti spoke to Lou, and then on the spoke to relationship, you may have something on there like times, and you may say, times : 4, and then you just increment that each time we speak to each other. So that is very much, that is a design decision, but yes, you can have numbers in your labels. Right, so we've got our sandbox it's up and it's ready to go. So let's just do a quick navigation around this. So what you can do, you'll have this down arrow here. So we click on the down arrow, and what you'll spot, we have a number of options. So first thing to mention is that the sandbox lives for about 3 days. So if you go through this and you go, I need a little bit more time, or you've imported your own data, or you're working with something, then what you can do is you can extend the sandbox, and that will give you an additional 7 days. So a sandbox can live for a maximum of 10 days. Don't panic, you can always spin up another sandbox if it expires, if you want to work on a new project, or you're picking up somewhere. You can invite people in your team to collaborate, and if you're finished with your sandbox, you can terminate that, and that will delete the sandbox. So for those of you who are interested in different ways of how you can connect to the database, if I click on the connection details tab here, what you will see is you have some information and the username. So for the sandbox, the username is always the same. So for those of you who have dabbled a little bit with Neo4j and you've spotted you're asked for a username and a password, then these are the details here. And then you can do the remote connection. So here you've got the Vault URI, and this is what you would use to connect. And if you need any of the port connections, you've got them there. Now, for those of you, and I know there was a question about Python, if you click on the connect via drivers, so you've got the Neo4j drivers, so you go and pick which is your language of choice. So let's go to the Python one as an example here. Somebody asked about Python. And what you can do here is you will be given an example of how you would go about connecting to the sandbox. So this is, you can go away, take this, get the, so you've got the instruction there for installing the Neo4j driver Python. So you can install your driver, and here you've got a code snippet that is telling you how to connect to the database. So here's connection details, and then here's a sample Cypher query. So you can go off, execute that, and then do other stuff. So there you've got for your languages there to get started with that. So that's a quick overview of the sandbox and various details there. And what we're going to do now is we're going to open up browser. So we click on the browser button together. That will start up Neo4j browser, which is a development aid to help us query and view our data. Okay, so when you start up Sandbox for the first time, and this is really great if you're new, you'll get this really handy little pop-up. And what this pop-up will do is it will show you the different areas of Neo4j browser. So you can click through it, and what it will do, it will describe the various components. So for example, here, this is our frame, and normally here we'll have a browser guide. So if you click on any of the other examples, what you will see is you will get you will get a guide that talks you through. So for example, the Panama Papers will talk you through the Panama paper data set. If you click on the graph data science one, it will talk you through the Game of Thrones data set that is used and so forth. So you'll get this guide and it will show you, and this guide will just talk you through how to navigate and work through. So I'm going to close this now. Please, by all means, do have a look at this in your leisure. And I'm going to give you the quick tour myself. So here is called frame, and you can close a frame by clicking this button here. And you can pin a frame if you don't want it to move around by clicking this button here. So this will make more sense when we get to the movie graph database. If I click on the side here, this will give us database information. Now, because we've not loaded any data, because this is a blank sandbox, at the moment this is blank. So what I'm going to do now is I'm going to show you how to start up your very first graph data set. And again, this is really, really cool because you can pick up at this anytime. So you can come back to this as many times as you like, and you can keep revisiting this as much as you need to. So I'm just going to close this pane. So to access the movie graph data that we're going to be looking at, what we're going to do is click on this write code button. So click on this right in where it says jump in code. And this is what we want here. We want the movie graph example. So I'm going to click on this button here, create a graph. And every single time you start up browser, you will always have that option. So that option will always be there every single time you load browser. So never fear, it's available. So what I'm going to do now is, because we're going to be referring to this, and I recommend you all do the same, we want to pin this right at the top. So if you've noticed, every time I've clicked on things, it's pushed frames down. So we want to make sure that this one stays at the top. So if I click on this pin here, that's going to pin that frame right at the top. So it's going to stop things from moving down. So that's going to make it really easy for us to look through things. Okay. To navigate through a guide, you'll notice we have these two buttons either side. So to progress, I press the button here, so on the right hand side, and if I want to go back, I can press the right hand button here. So that's how we can navigate through the guides. You'll notice we have these little blue type arrows here. So if we click on these will send us up to the relevant point in the documentation to explain to us how these functions work. And what you'll notice, we also have these big grey blocks, and these grey blocks are executable statements. So if I click on this button here, what that will do is that will send the code up into this box here, and this is where we write our Cypher queries, and we can run them. So this is a really convenient way for us not having to type out, because this is a big statement, of not having to type out all of that code. And then we can run code by pressing the play button. So I will do that in a second. What I want to do is just quickly talk through what's going on here. So this here is going to be creating all of the data that we're going to be working with. Oh, you want to quickly show you how to access the movie data? Of course. So let me close browser again. So I'm going to open browser. Just let that load. There we go. And to start the movie graph, we first click here. So where it says jump into code, we're going to click on the right code button. And then we're going to, this will pop up where it says movie graph, and then we just click on create a graph. And this is exactly the same for any Neo4j browser, whether you're using the sandbox Neo4j, whether you're using Neo4j desktop, you will always have that option. It is always available. And that's how we start up the movie graph. So again, I'm just going to pin this so it doesn't go away, and that's how you get it there. And it's always available. And if you accidentally close the frame, where it says write code, just close browser and start it up again, and it'll be there. It'll be there. Okay, so let's have a look at this code. So I click this code snippet and it sends it up to the query box. And what you can do is, if you want to make this bigger to have a look at it, because you go, oh, there's lots of lines here and I want to make it a bit easier to read, you can press the escape key and that will make it bigger. And if you want to shrink it back down again, press the escape key again and it will reduce the size. So I'm going to make it big. And let's just have a quick look at the data we're going to be loading. So this should all be familiar because we've already been through some of the syntax. So let's see what's going on here. So we've got create keywords. That means we're going to be creating something. And what we can see here is we're going to be creating a node because it's wrapped in the round brackets. So we're creating something with a node label of movie. We're giving it a placeholder name of matrix. And we have our properties in curly braces. And in the curly braces, we can see we've got a number of properties. So each property is separated by a comma. So we've got a property key of title, and we've got matrix as a value. We've got a property key of released, and we've got 1999. So that's the released year for the movie. And we've also got a tagline property key with welcome to the world. So that's our node. And we can see we create a number of nodes here. So we've got, we also make some person nodes as well. So same convention, we've got our sort of our placeholder for our variable name. We've got our label for that property, label properties. And then what you can see after we've created all these nodes, we're using those placeholders as an easy way to refer to those nodes that we've created. And then we are creating a number of relationships. So we're defining how these nodes are connected to other nodes. So again, we've got the square brackets. We've got that acted in relationship. So we're saying what the relationship type is. Because we are creating these relationships, we have to specify relationship type and direction, but we can ignore that if we're doing a match later on. And then here we're adding some properties. And what you will spot is we're putting in an array, because what you will see that some of the roles that people play in the movies, they play more than one role. So I think Tom Hanks is one where he plays more than one role. So you can store arrays as properties as well. So that's what's going on here. So we're creating a bunch of nodes, and then we're creating the relationships that say how those nodes are connected. So you can see we've got a lot of that going on. We've got lots of different movies. So that's creating all of our data. And then at the very bottom, we have our query with Tom H as A, match A, acted in, M, directed in, B. Don't panic. I'm going to just talk you through what's going on here. So what with does, so we're doing a bunch of functions, and sometimes we need to tell Cypher that we want to remember one of the variables that we've done. So we've done these creating, but actually we have a new part of the query that we want to execute. And this new part of the query, we want to use Tom H. So up, you'll notice further up, oh, here we go. We've got Tom H now. We haven't defined him up there. But we've somewhere up there, we created a Tom Hanks node, and we created a container for that Tom Hanks node called Tom H. And then what we're saying is, with Tom H, and we're going to reassign it a new name. So we're now reassigning Tom H to another new container name called A. What I want to do is I want to match A, which we know is a reference to Tom H, which is our Tom Hanks node, find where Tom Hanks acted in something. And because of our data model, we know that that's going to be a movie, because it's always actor to movie to actor to movie to actor. Acted in M, so M's going to be movie. And then we want the director. So we've got the director relationship. So return A, so it's going to return the Tom Hanks node, return M, return the movie, and return D, return the director. And limit 10, so we're just saying just limit it to the first 10 nodes that meet that criteria. So that's what's going on there. So the question that we're asking here is find all of the directors and the movies where Tom Hanks has acted in that movie. That's what's going on. So that's all good. That should all be familiar. And what we're going to do is press the play button, and that's going to load our data. So if you run that, and we're going to get some data in. So let's have a look at some questions whilst that is going. So what have we got? How secure is the data we send out on Neo4j? That's very much going to very much going to depend on your infrastructure setup. So as with any other database, that's all going to depend on how you set up your environment, how you've locked it down, how you've zoned it, and so forth. So outside the scope of this session, but please do have a look at the documentation. So we have a lot of documentation on best practice for securing your data. We've got a question on, are there any standard conventions for using a quote or single quote for strings? Right, so you can use single quotes, you can use double quotes, you can use a mix of single quotes and double quotes, but you must make sure that if you start with a type of quote, you end with a type of quote. So I could do something like, let me give you an example. I could do something like return USB board. So I could do that, and that's fine. Without the dot, of course. That's fine. So I can mix, but as long as whatever I starts with the same quote, ends with the same quote. But apart from that, there is no real convention. It's whatever you like, and where you could easily, if you like, again, beyond the scope of today's session, but you may be using stored procedures and functions where you're calling quotes, and maybe you want to use the different quotes to differentiate between what's going on. But that's up to you what you wish to use. Does Neo4j support API transactions? Again, the drivers. What else have we got? This seems like GraphDB would be good for JSON stored data. Yes, so you can have JSON type objects. And in fact, we'll have a look when we return some data. You'll notice it looks like that structure. And maybe something it's worth having a look at is do have a look at Neo4j and GraphQL. So my colleague Will Lyon has done a lot of stuff around that, and I think you'll find that super interesting. And let's have a quick look at some more questions. Is there a way for Neo4j to automatically generate relationships, machine learning or something along those lines? I would suggest you have a look at the graph data science libraries. Again, that will be beyond the scope of today. Can Python dictionaries be easily translated into Neo4j? I'm afraid I don't know enough about Python, so I couldn't answer that. But I would suggest if you have a look at the Python developer guides, that will hopefully, there'll be examples in there. Oh, and last question, how do you make the window large again? If you click in the query box and press escape, so press escape to make it big and then press escape again to make it small. So hopefully all of you have loaded that data, and you will end up with something like this. Now, if you want to make your results windows bigger, you will notice these diagonal arrows pointing outwards. So you just click on that, and that will make it big. And same idea again. I can click on that, and it will make it small. So if we click on that, we can see what's loaded. So here we can see all of our directors. We can see all of our movies. And you can see an example here where Tom Hanks acted in a movie as well as directed in a movie. So there's your example. There's your example there. We've got our query. So we've got some data loaded as well. So let's have a quick look. So first of all, if I click on table, so this is going to give us a text representation of what's going on. And you can see we have these like JSON-esque type representations of the nodes and the relation of the nodes here. So you've got here the Tom Hanks node here, we've got the movie node here, and we've got the director node here. So let's encounter that. So now we've got some data loaded. What we can do is if we click on this picture of a database here on the left-hand side, it's now going to give us some information about what we've got. So we see here we've got a total of 171 nodes. We've got a total of 256 relationships, and we can see what node labels are in use. So we've got movie and person node labels in use, and we can also see what relationship types we've got in use. And also we can see what property keys we've got involved. So now we're starting to get some information about the database. So another thing we can do as well is let's have a look at what our data model looks like. And we can do that by doing call db.visualization, schema visualization. And we can run that. And let me just go back to graph. And this is effectively our data model. So this is what we're looking at. And what we can see is we have got a person node. So that's our nodes with a person label. We've got a movie node. So that's our nodes with a movie label. And then we can see the different types of relationships that we have that describe the relationship between person to movie. So we've got a directed relationship, a wrote relationship, produced, reviewed, and acted in. So all of those different types of relationships. And what we can see, we have a self-referencing relationship here as well. So we've got person follows person. So straight away we can start to see what's going on there. And that is our data model. And again, what you may have noticed is we didn't declare a data model before we loaded our data. So Neo4j is schema light. So you effectively do your schema, your data model on write. So you write, as you write your data, that defines your data model. And that's what it is. So we didn't have to do anything. And if we decide we want to change something, so let's say we want to introduce a new type of node, so let's say we want to start having genre, so we want to say what kind of a genre a movie has, we can do that just by writing that data in. So we have that huge amount of flexibility. If we decide we need to add a new property, so let's say we want to add a genre property on movie instead of a genre node, we can do that too. We have that flexibility to change and tweak this accordingly. So that's our data. And what we shall do now is we're going to click on the next pane, is we want to start doing some querying. So what I'm going to do now is I'm going to give you some time. So you know now how to get the queries in. So you can click on the hashed box, and that's going to send your query up. So what we're going to do now is I'm going to give you about 5 minutes, and what I would like you all to do is to have a look at each of those queries, and before you run it, try and have a think about what that query is going to do. So have a look at what the query does and think what you expect the response is going to be, and then run that query. So we'll just stick on this page for now. So let's go until about 4 or 5 minutes. Have a go at each one, and then we're going to continue as a group. And if you get stuck or have any questions, put them in, and I shall keep an eye out.
Lou, also, just a heads up, Adam is in here too from our team to help answer questions.
Cool.
Yeah, this is great. This is really great. Thank you.
So we had no problem at all. So for those of you who've got some questions about how to, let's go. How did you get this window with graphs? Okay, so you want to have a look at the data model. So bearing in mind that we've pinned this one. So for those of you who've run the query, you may need to scroll down a little bit. So for example, here, I'm just going to get my mouse back. And if I scroll down, you'll see here is my query. So the Tom Hanks one. So for those of you who've clicked on table and you're thinking, what text? Just check to make sure you've clicked on the graph node, and that'll show you that visualization. And if you want to have a look at the graph data model, then what you want to do, call db and you can either type db.schema. There you go. db.schema. And don't forget to scroll down because we've pinned that window at the top. So your queries will be appearing at the bottom. So even if you're running these ones, don't forget to scroll down. There you go. That's how you can see it. So call db.schema. And you can view your data model. Okay, so we've got a few more minutes. So I'll let you have a look at those queries. Try to predict what that query is going to do and then run it.
These other questions, they may have been answered. If you could just confirm, and I can move them over into answered.
They might have been answered by the team from Elaine and Adam. So I don't know if Lou would know. It would be maybe Elaine and Adam would just have to, I guess. Please put your questions in the Q&A tab when you guys have questions. Thank you. Yeah, so they might have been answered. I don't know which ones have not been answered yet.
It's all good. Well, if I see them, I'll answer, because there may be other people that are thinking the same question. But
yeah, if you see something that like takes more of an explanation rather than like a quick answer, then yeah.
It's all good. So is Neo4j schemaless, or can we have schema-based models too? So yeah, so I would describe Neo4j as schemaless, schema light. So we can also put in, again, we're not going to cover it today, so you can put in constraints around, nodes must have certain labels, or nodes must be unique, and that kind of thing. You obviously have light, so you can define the schema through your application layer, and certainly people use Spring as well to force things. So you have ways you can force schema to. But inherently, it's schema light, and we define our schema as we load the data. Okay, so hopefully you're all getting on well. So we have about half an hour left in the session, so we'll continue to the next part. And bearing in mind that you can keep coming back to this at any time. So this is what's really great about the movie graph, is that it's so easy to get to, and you can just keep working your way through it and work through examples. So let's just do a quick question. How can I get all of the actors which names start with Tom from the database? So, okay, I'm going to give you a little hint. So remember, we use a where clause. So think about using contain. So I think we may cover it. So if we don't cover it in this example, then we'll bring it in at the end. So I'll show you how to do that. So let's click onto the next page. So we should be on number 4 of our guide. So again, I want you to do the same idea. So again, I'm going to give you about 5 or so minutes. Try and think, try before you run the query, step through the query and try and think what the query is going to do. So same idea. It's good practice to try and guess what's going on. So again, I'll give you another 5 minutes to work through that. And if you've got any questions, pop them in and we will answer those. So I've got a question here. Why do some of the queries return a graph, and why do some of them return a table? Brilliant question. So what you'll notice a bit of a difference, that if we return a node, like let's look at this top question here. Let me put my mouse back. You've got this question here where it says match Tom person, Tom Hanks, etc., etc. Return Tom Hanks movie. So here, you notice how we've got a reference, our variable, to the node. So here in our Tom variable, we're storing all of the nodes that have a label person with the name property of Tom Hanks. That's getting stored in Tom. And then here, Tom Hanks movie is storing all of the movies that have an active in relationship off of the node that matches that criterion, Tom Hanks movie. So effectively, these two containers are holding the nodes. So when we run that query, that's going to return the nodes, those, not the nice pretty visual. However, if we have a look at this query here, again, we're looking for we're looking for all nodes. So we're not specifying the label. So we can do it here because it's a small data set, but as your data sets get bigger, you probably want to use a label. But here we're looking for all nodes that have the property key title with the value Cloud Atlas, and we're looking for the directors. So you notice here we're doing .name. So when we do that dot, we are saying we're accessing the property. Now the properties are going to be strings or numbers or arrays, but they're not graphs. So we're going to be returning those discrete values, which is why in this scenario, if we run it, we're going to be returning a table because we're not returning nodes. Now, and do feel free to have a go at this to just sort of see the difference and what happens. If I removed this bit here and it was just directors, now we're pointing back to just the nodes, and then this is going to return that visual that we're familiar with. So as soon as we we return just properties, then that's just going to return the table. So hopefully that makes sense. Do have a go with it. Have experiment what happens when you add the property, return a property, and you don't return a property, to see what happens. Okay, so we've got a question here. As you mentioned that unlike SQL, where you need to have a schema and a data model, with Neo4j, you do not need to have a data model, but create one with the commands. Yeah, so if you think about when you're, so you think about when you're loading some data in SQL, you have to define ahead of time what your tables look like, don't you? So you have to say, I'm going to have this table is going to have these column headers, etc., etc., etc. With Neo4j, you don't have to do that. So basically, you are defining what your data looks like by writing your data. So when we did create colon person, open brackets, name colon Tom Hanks, etc., we're then defining, when we do that create, we're saying, okay, we have a node of labeled person, and that person labeled node has a property key of name. That's what's going on. And the really nice thing about that, so as well as having that huge amount of flexibility, is maybe we've got a customer database and we've got the customer name as a node property, we have their date of birth, we have their email address. Let's say we also wanted to capture Twitter handles. Not all of our customers are going to have Twitter handles. And the really beautiful thing is we only write that property if it exists. So we don't have null values. We don't have these sparse matrices of data. And that's really, really flexible. So we can do that. So yes, it's very much this idea of we're defining our schema as we write our data. Okay, so how are we getting on with these extended patterns where we're starting to bring in the relationship? Going well? Right, so what we shall do is let's move on to the next one, because we have some really fun queries coming up, including a Kevin Bacon number. So let's, hopefully you're getting ideas. And again, please do, at your leisure, spin up the sandbox again. Again, you can always come back to it. You can spin up a new one and work through these with more time. So I'm going to do the next one because this is a fun one. So our next query, so we should be on 5 out of 8 in our guide. We are going to have a go at Kevin Bacon number. So let's just talk through this query first. We've got some new things coming in, so I'm just going to talk through what's happening in these two queries, and then I'm going to let you have a go at running those, and if you're feeling brave, maybe also change which actors we're looking at. So let's have a look at the first query. So let me bring it up in the window. So we've got the first bit. So this should be familiar to us. So what we're doing is we're finding person nodes that have got a name of Kevin Bacon. We know we're going to have a reference to some node. So we've not specified what kind of node, but we've got a container called Hollywood. So we're going to store all of those nodes in there because we've got the curly braces. And what we've got in the middle here is, notice we don't have a direction, so we don't care about the relationship direction. And what this bit of syntax in here says is, oh, actually, I want you to start from the Kevin Bacon node that we found, and then from between 1 to 4 hops. So basically, we're not just saying Kevin Bacon to movie or Kevin Bacon to movie to person. What we're saying is from Kevin Bacon to movie to person to movie to person, 4 hops. We want you to find all of those nodes that are connected up to 4 hops away from the Kevin Bacon node, and then return them. And notice we've got the distinct keyword there. So bearing in mind there could be multiple paths, and this is because if you think about it, you could have a Kevin Bacon that goes to a movie, that goes to an actor back, that comes to an actor to another movie that comes back eventually the same movie, because you can have actors who've been in multiple movies at the same time, if you see what I mean. So you can have more than one path. So that distinct is just saying, just show us when it shows up the first time. We don't need to know about the multiple times. So that's what's going on. So this is the notation for that. So *1 ... 4. So quick advance notice, please don't change that 4 to anything bigger. You can do it smaller, but don't make it bigger. We'll talk about that in a moment why. So that's what's happening in that query. So that's going to be good fun. And again, if you feel like changing Kevin Bacon to Meg Ryan, Tom Hanks, have a go. In fact, if you can't think of any actor names, what you can do, if I click on the database button here, if I click on person, that will bring back a sample of nodes. So it'll bring back 25 person nodes here. And what I can do is if I click on the table button, it'll give me a nice list and I can copy and paste the names. So you can have a go at that. If you want to try changing what names that you do, if your hops out, then have a go at that. Try changing the names. So that's the first query. So that's our Kevin Bacon number. And then our next query, so let's just quickly talk through that. This is going to do shortest path. So this is a really, really cool thing that we can do with graph databases. And what's happening here, so we've got a slightly new thing going on here. So we've got this convention of P equals. So what that does, it says, please take whatever my pattern is going to be. And you're going to see our pattern here, which is this pattern here. Take this pattern, and I'm going to store that in my variable P, which is a path. So that basically takes all of the nodes and relationships and it puts it in its own variable. So that's what that P does. So it's a path. And then what we do next is we're saying, well, I want to have a look at all the different paths that connect the person Kevin Bacon to the person Meg Ryan. Please don't in 2 seconds why. But we've wrapped, and with that pattern, it's going to say, find the shortest path that connects Kevin Bacon to Meg Ryan and then return that path. So that's why we've done this P equals, because we want that specific path of all the nodes and relationships, and we want to bring that back and visualize it. So a quick comment on this star. So we saw star earlier when we did star 1.4. So star basically says we're looking at a variable length of hops between nodes. So up until now, we were just looking at one hop. Now we're looking at more than one hop, and we can do that by using this variable. But the thing to bear in mind is we have to be very careful about how we use this. And if we do this, this is going to look at every single conceivable path that connects Kevin Bacon with Meg Ryan. Now, we only have 273 relationships, but we have something like 173 nodes. And we could, I've not done the maths, but we could easily have millions, if millions of combinations of how Kevin Bacon and Meg Ryan are connected. And these will be unique paths. And this query will potentially never complete because, you know, it's a small instance and there's so many paths. So we should never run that query like this. However, because we've wrapped it in shortest path, what shortest path does is as soon as it's found a path that's, say, 5 hops long, as soon as something's going to be longer than 5 hops, it doesn't even bother going down that path. There's no point. And it just keeps trimming until it finds the shortest path between those two nodes. So that's what's going on with that query there. So what I'm going to do, I'm going to again give you about 4 or 5 minutes, because I suspect some of you may have been a bit keen and run those queries anyway, and that's fine. It's good to explore. So have a few minutes running those queries. If you want, try changing the names as well. So maybe you want to see how far Meg Ryan and Tom Hanks are and that kind of thing. So again, we'll give you a few minutes to have a go at that, because we've got another fun example coming next where we're going to do a simple recommendations engine. So again, I'll give you a few minutes on that and we will go on. And again, you can have a go at this in your own time. This example is always available to you. So there's a quick question about, just to repeat what star does. So what star does basically says unlimited hops. So star on its own is unlimited hops. And what we can do is we can put like a little brace on that unlimited hop. So we can say, well, actually, we want to go up until a number of hops. So star on its own is unlimited. But what we can do, and let me click back on this example here. Here we're saying up to 4 hops. So a minimum of 1 hops and up to 4 hops. But star on its own is as many as. Okay, so what I'll quickly do as well, whilst you're having a look at that, I've got a question about how can I find all of the actors. We start with the name Tom from DB. So let's have a quick example of how to do that, Tom. So if you wanted to find all of the Toms that I mentioned in the database, there's a number of ways of doing it, and one way we could do it is we could do this. So match Tom, because we're looking for Tom's person, where Tom.name, and let's say we want everyone whose name starts with Tom. So we do starts with Tom, it's case sensitive, and then we can do return Tom, and that's going to return all of our Toms. So we have a few Toms, don't we? We've got Tom Hanks, a Tom Tyquer, a Tom Cruise, and a Tom Skerritt. So there you go. There's your Toms. So that's one way you can return Toms. We've got another question. Why do we need to alias Bacon and Meg in this shortest path? I don't think we do. It's up to you. You don't have to alias. So there's certain conditions where you're not referring to it, so you don't have to provide an alias. But it doesn't hurt. It's not going to cause any problems. So I wouldn't worry about it. It's just in the guide they've used an alias, but it's all fine. How can we find the actors who are furthest away from Kevin Bacon? Oh, I love that question. That's a really great question. I can't think of a solution straight away. So what we can do is we can do a bit of a cheat. And let me show you a bit of the cheat. So let's go back to this example here with the hops. So what we could do is the length of the path. So if I did match p equals that, then if I return, I think I can do this the right way around. I could do something like, I just got to remind myself, can I do a size on p? I don't think this will work. Maybe. Quick route. No, okay. So what we can do is I could do something like this. I'm not going to explain the query. I'm just going to show you a trick. So we can unwind the path. We can extract nodes out of the path and unwind them, and then we can do a count. So what we could do is something like this, which is unwind with poly. Probably do something like this, and then at least we can say within our confined path of how far we're saying we want to go, tell me who's the furthest away within the confines. So we could do something like that. So if I come to the table here, so we've got there will be a way of doing this. I just need to I need to probably distinct that. So you can kind of get an idea. So it'll be something like that. So we can count the number of nodes in the path away from Kevin Bacon. So I've played that, but it'll be something along that syntax to do that. Okay. Let's move on to the next one, as we only have a few minutes left, and we want to have a go at the recommendations engine. We're going to build a really simple recommendations engine. So that's the last one that we're going to do, so we can explain what's going on. And what we're going to be doing here is we want to find some co-actors to recommend to work with Tom Hanks in his next movie. And in this next movie, you know, Tom Hanks wants to work with people that he's not worked before with. However, how we're going to recommend these potential co-actors is by the people that he has already acted with. So the example here, let's talk through what's going on in the query, is, so we're matching Tom Hanks, our Tom Hanks node. We want to find, you know, all the movies he's acted in, and we want to find all of those co-actors that he's acted with. So that's our first co-actors. Then the second part of our query, we're using those co-actors. We then want to find out all the movies that they've acted in and all of their co-actors. So they're the co-actors. And what we want to say as well is these co-actors must be people that Tom Hanks has not acted with before. So that's that where not. So that's negating this statement. So where not, Tom Hanks is already connected one hop away from those actors. And we also want to make sure that the co-actors we suggest aren't Tom. So that can happen because these are two separate statements. So notice that we can separate more than one match statement with a comma. So once we've done that, so we're trying to find all of the co-actors of Tom Hanks that Tom Hanks hasn't already co-acted with before, and they are not Tom Hanks. So that's what's going on in that query. And then what we're going to do is we want to return the co-actors' names as recommended. So we can do this, and this is going to give us a helpful column title when we return that data. And this is going to be as a table. And the other thing we want to do, we need to order this in some way. And a sensible way of ordering the strength of the recommendation that we're giving with regards to co-actors is going to be by the number of people that have worked with co-actors. So the more co-actors that have worked with this recommended co-actor, the higher we want to recommend them. So that's what we're doing. So we're ordering it by strength. So that's what's happening in that query. And then in the second query, so this is so that one there, that is a great example of recommendations engine. So this might be an example of how we're doing friends of friends, or we're trying to detect potential contacts that we may know, because we're looking at, you know, the strength is, well, we know we have these people all in common that we know, so maybe we might know each other or our paths are crossed. So you got that. And then the second query, let's have a look at that. So what's going on here is we're matching Tom Hanks and you know, the movies he's acted in, and then we find the co-actors. And then what we're doing here is using those co-actors who've acted in the movie with Tom Cruise. So what we're doing here is we're trying to say, well, okay, obviously doesn't happen in real life, but let's say Tom Hanks and Tom Cruise have never met before. And what we're trying to do is we're trying to find some common friends that can go away and introduce the Toms to each other. So that's what's happening in that query. So what we shall do here is, again, I'm going to give you a few minutes to have a go at this. So again, you can explore this. So have a look at what's happening in the query. Try running the queries. Maybe you've got a bit of time as well to perhaps change the actors' names to somebody else. And then we will wrap up this session. So again, if you've got any questions, do pop them in and we will keep an eye on those and answer. So we have a question on, are there any visualization libraries that allow you to show these graphs in a web browser? So I would recommend you have a look at our developer guide. So I will bring up the link to that shortly. So we have a section there on graph visualization tools.
I'll put the link in.
Oh, fantastic. Thank you. So within there, so we have a section on graph visualization. So we have got options around, so you've got Neo4j, there's lots of third-party libraries. If you're just looking to visualize the data, we've got Neo4j Bloom, which is more data exploration rather than writing Cypher queries. So you've got a lot of options there, and you've got the link there in the chat. Another question that's come up, which is what does the diamond symbol stand for? So the diamond symbol is not equal to. So the two arrowheads creating a diamond is not equal to. Okay. Oh God, let's give an example of not equals to whilst you are working on the whilst you're working on the recommendations engine. So I could do something like 1 is not equal to 2, and that should return true. There we go. So 1 is not equal to 2. Okay, so we've got another question. In finding cofactors to introduce two toms, why does the visualization have duplicate representation? Let's have a quick look at the query. So what might be happening there is, I haven't looked through the whole data, but I'm going to speculate what's going on there is you think about the co-actors. So there'll be co-actors who've been in more than one movie with Tom Hanks. So that the Tom Hanks and co-actor A could have been in 3 or 4 movies together. So that's why you may have that repeating going on, just because there's more than one path that connects those people, and the same idea with Tom Cruise as well. So you're thinking about those paths. So again, we could probably do something on strength as well, where we can say, well, you know, that co-act, you know, we could sort by the number of different movies that have appeared together and do that strength thing again, where we only want to have the co-actors that Tom Hanks or Tom Cruise are going to know really, really well because they've been in so many films together versus just the one film they did 20 years ago type thing. Okay. Oh, yes. And another thing to point out, which Rose has pointed out on the chat. So something to bear in mind, when you create data, no check goes on to see whether that data already exists. So this happens with the movie data set. So if you run the create statement several times, you may end up with duplicates or triplicates of the data. So that may be another thing that's going on. So I'm going to show you a little trick, which we do in the next slide anyway, to get rid of the data and start afresh. So let's do that now as we move towards the end of the session. So what you'll see on the penultimate slide is we have a couple of statements. So if we wanted to delete all of the data in our graph, what we can do, and this works for small data sets, is we can do this statement, so match n. So remember at the start of our slides when we were going through Cypher, match n will match every single node in the database. So we do that, so it matches every single node that we have in the database and puts it in our container n. And then we need to detach those nodes from the relationship. So detaches that node from relationships, and then delete n deletes everything in the database. If we wanted to just delete person node, then we could do match n : person, detach delete n, and so on. And then the next one, so we've done this before, match n return n. If we've got no data, it will return nothing. But again, that matches every single node in the database and then returns n. So what you can do, if you're happy to do so and clear the data, don't forget, you can always go back to movie graph and reload that data. You can try doing match n return n to see what data you've got, and then you can try deleting it. So I will let you clear up on that, and then we will quickly touch on further resources. So a quick question was, can you please describe count star in the first query? What does star mean? So when you do count star, it means count everything, and everything will depend on what you've pulled in the previous query. So here at count star is going to be all of the co-actors. So that's going to say what we're counting here are all the co-actors. So count star will be count all the co-actors. Okay, so what would be really good, I hope you enjoyed that example. Please, please, please have another go. Sandbox is always available there. If your sandbox expires, you can always spin up another one. That movie graph there is available. What do you want to do? Hopefully you're all super excited and you want to learn more. You're thirsty for knowledge. You want to keep going. So what I'd like to do is just highlight some resources, and we have many, many resources. So first of all, we have a PDF book available on graph databases. So this is really good as a primer to describe, why graph databases, where are good places to use them. It touches on some graph data modeling and so forth, and introductions to Cypher. So that's available for free. We have a fantastic online training resource. So we have topics there from introduction to Neo4j, to graph data modeling, to those of you who are interested on the setup and configuration of the product. So the training there, it's online, is completely free. You can also get professional certification, so you can become a Neo4j certified professional. Again, that is completely free. So that's something as well you can do to continue your journey. We also have our YouTube channel, and we have a huge amount of content on there, from how to, best practices, product releases. We have conferences we do, so we have Graph Connect, which is our in-person conference. We've got nodes, which I'm sure Corinne will mention again. If not, I'm going to mention it quickly as well. So we have our Nodes 2019 material on there. We've got Nodes 2020 coming next month. And once that's over, all of the recordings will be up on our YouTube channel. So that's another really great place as well to have a look at stuff. And again, we have much content that we've had the link posted to the developer guides as well. So you've got some links there to have a look at to continue. So again, you've got the graph database book, the online training, and the YouTube channel. And some of you may have come across it. If you haven't, it's not a problem. So last month we had Summer of Nodes, and this was a set of fun challenges, both beginner and experienced. So for those of you who are new to Neo4j, check out the beginners challenges. So it's over now. Still go and have a go at these in your leisure. And we have lots of fun stuff, from thinking about how would you model a barbecue, what about exploring the Museum of Art in New York, so you can go and explore the various collections there. We've got a murder mystery there, so you use Cypher to solve the whodunit, who was the culprit. And we also have a secret sandbox, so you need to go via the article, where you get to grips with Neo4j Spatial, so you can work and explore the points of interest in Central Park, and that's where you get to have a go with shortest distance and all of that good stuff. So you've got those. So you've got the starting point there. So I need to update that address. That is r.neo4j.com. So let me just let me quickly update that. So that's I've got that should be r.neo4j. My apologies there for those of you who wonder why the link doesn't work. So start at this link here. And actually, we'll just leave it like this. So start there, and then you can work your way through those articles. They're great fun. We did live streams of those, so you can watch the recording of the live stream. So we've got the hints, we've got the solutions, and you've got everything there. So I think that's a really fun way to get started and sink your teeth into Neo4j. Yes, the video will be available. The recording of this video will be available. So for those of you who want to rewatch it or you have to drop off, it will be available. And last but not least, if you want to ping me any questions, you've got my contact details there. Again, do join us on the community website. So that's community.neo4j.com. Come join us if you've got any questions, if you're working on any fun projects, if you need some help with something, come and let us know. So thank you once again for joining us. I hope you've enjoyed it, and we've gone from what's a graph to building a recommendations engine. So please do go have another go at the movie graph example. It's always available there. If you've got any questions, let us know. And without further ado, thank you very much.
Lou, that was awesome. Thank you so much.
Thank you. Thank you.
Really, it was amazing. And Reshma, did you want to say anything to close off?
Oh yeah, I just want to say thanks everyone for joining us from all over, and we look forward to seeing you at Nodes 2020, and maybe we can compile the links somewhere.
Yes.
I might, yeah, I can work
We'll,
on it.
we'll have a list of links, so definitely, because I think this is going to go out onto YouTube. So as an absolute minimum, we'll have all of the links that we mention in the description as well, so you're not having to sort of quickly type down and write them in. So yes, we'll have the list of links sorted out.
Okay,
cool. Awesome. So thank you, everyone. Thank you, Lou. Thank you guys all for joining. Hopefully this was good and helpful, and we'll see you at Nodes 2020.
Yes, Nodes 2020 would be great.
All right. I am in the recording. And